Then I will dance for you. At the end I will dance for you. How about that? What's your hint of dancing? Yes? Yes? Okay, did you try? Try to solve it, right? What's the answer? You already did it? I was so proud when I was in high school, you know? I was of these nerds. We were about 2 or 3 nerds in that class, of 3 people, 35. So the exams would come forth, you know? I was really good on geometry because I loved it. It was just like my God. I was staying until 5 o'clock in the morning doing geometry problems, really hard problems actually. So geometry, algebra, trigonometry, physics, I was really good. So I had the fun to come out of the class first one. Out, first. That pride inside. Right? How long can you live with that pride? Someday you just have to kill that pride. Otherwise you're going to find rest, no rest. So I feel good, you know, I was the first one all the time to come out of the room. And then the teachers would say, you know, what are you doing? What are you doing? He always comes out first from the class. What does that mean to me? To make wrong choices. That made me to make the wrong choices. I made a wrong choice. What to pick up for my career as a student. I was dumb. Why? Out of pride. Grumble. It took me many years suffering during my married life, whatever, to figure out what I love to do. That's ridiculous. Wasting my life. Don't do the same thing. Are you ready to do it? Okay, let's do it. So what do we have? We have the mass. You put down what we have. The mass is 18.2 grams of a monoprotic acid. So monoprotic acid, that means it gives you 1 proton, right? And then the rest is a 9. We don't care, right? We don't care what it is. It's just A. And then, what do we have? We have 0.10 moles per liter concentration. We have volume of 5 liters. And the question is, HA is what? What is it? Identity. 3 lines means identity. What is it? Okay, well, how about, we know the mass. What will give you the identity, really? The identity will come from the mass of the molecule, or the molar mass. Yes? So, what relates the molar mass, which we find what acid is, because we know what H is equal to 1. If we know the molar mass, that means the whole thing. How much we know A, we go to periodic table and we know what it is. Yes? So we need to find out how the molar mass of this acid acid relates to mass. Well, do you know any kind of thing that relates to it? Of course you do. What is it? The number of moles is equal to the mass divided by the molar mass. So, I will find out what A is, therefore what HA is, because I know what H is 1, if I find out the molar mass of it. This one. I know this, the only thing I need to find it is what? Number of moles. So from here, when you're looking, do you know how many moles you have? Of course you do. Because you have what? 0.10 moles per liter times 5 liters. And that will make you, in moles, how many? 0.50 moles of HA. So you have the number of moles, great. And Therefore, the molar mass from here is going to be equal to mass divided by number of moles. So it's going to be 18.2 grams divided by 0.50. What is that? What's the 0.50 we said? Moles, right? So that will give you 36.4 grams per mole. And because you know 1 mole, I don't have to do that, I'll do it for you. 1 mole of HA is equal to 1 mole of H and 1 mole of A. Yes? And this one, you know it's 36.4. You know this is 1. It's in grams, right? I don't have to put it because I already done. Plus X grams. So if you solve for X, you will find out that it's 35.4 grams. That's for A. So what A could be? Nitrate? That's too big, isn't it? NO3 minus. Monoprotic acid. So you know a few monoprotic acids. Could be nitric acid, hydrobromic acid, hydroiodic acid. No. You go there and you find out the halogen is Cl. 35 point approximately, right? So then the answer is this one comes to be the Cl, and so the acid is HCl. Yes? You want more problems or you want music? And go home. More problems? These people like problems. I'll give you problems. Okay, there you go. More problems. Photons. Remember, when you have the equation energy is equal to Planck's constant times frequency, E is equal to H times D, that refers to the energy of one photon. One photon, no mole of photons, one photon, right? Because many times in the books it's not clear. Okay, if that's the case, what do we need to find out? We need to find out the energy, how much it is, in kilojoules per 12 photons. You see, really you must write these things down. You have to write it down, otherwise you don't start solving a problem. Remember 1 hertz is equal to 1 second minus 1. 1 kilohertz is 10 to the 3rd per hertz, right? Remember this relationship. And if you want to find out the energy of 12 photons, I better find out first for 1 by using the equation, right? So A, E, usually, like I said, I don't know books that they do that, and it's a little bit confusing because it's in the air, from what I remember as a student for years. So I like to put it this way. Energy per photon, right, is going to be equal to H times me. So if that's the case, you know H from the back of your exam. Joules times seconds times the frequency. Oops, that's seconds. So the frequency should be in seconds. To have seconds. And we don't have seconds. Its frequency is 801 kilohertz. And if I want to use frequency here, I better have the same kind of thing. So this has to become seconds. To have seconds in it. Yes? A function of seconds. So I better change it then. So that would be what? That would be 800 times 1,000 curved because of this. And then that would be actually 8.00 times 10 to the 5th hertz is the same as second minus 1. So I take that one and I put it there then. And this one goes away with this. And I will have joules. So that will give me 5.30 joules. And we want it in kilojoules, you see? Kilojoules. So we'll have to go to kilojoules. And that will make it 5.30 times 10 to minus 31 kilojoules. Remember, that's per photon. Okay? And if you want for 12 photons, then what are you going to do? Multiply by 12. So the answer should be 6.36 times 10 to the minus 30 kilojoules. There you go.